Squareness Comparator Surface Gauge. This is the best 3D printed Squareness Comparator surface gauge that you can make easily by yourself. There's no machining involved, or very little. I will show you in this video how to do it, supply you with the files, and also show you how to use it properly. This video is quite lengthy, but it's worth the watch. I've added an index so you can go back and forth from chapter to chapter. Before we get started, please take a moment to like and subscribe. It's free and it'll help me out. Okay, let's get started. Using the chapter index, you can fast forward or rewind to the area that you want. A fast look at the design in SolidWorks. Okay, let's start with the assembly. So I already have it assembled. Makes it a little bit easier this way. So this is what the unit looks like fully assembled. An example of setting up and printing in the 3D printer. Okay, for those of you that are not familiar with going from a SolidWorks drawing to a 3D printed part, I'm going to show you the steps to do this. So I have this piece here. This is the part that I designed, one of the blocks here. Okay, so now I have the design of what I want. Now I want to make this into a 3D printed part. It's relatively simple depending on the software that you have. So what I would do is I would go up to here and I would go save as, and then come down to here and I want to save it as an STL. Right there, an STL file. So I already have this saved, so I'm not going to save it again. I have it saved right here. So when I click onto here, because this is an STL, my software for 3D printing will automatically open. So we click on that guy. You get your standard advertising. Now it's imported just like this. Now I cannot print, because of the shape of the part, I can't print it like this because I'll have all sorts of problems. So what I need to do is stand it on its end. So I'm going to rotate it. Let's try this guy here. There we go. Let's rotate that around. Nope. There we go. Rotate it that way. You don't have to rotate the second one. I just like doing it that way. Now, the most important part is you cannot print in the air. So I have to be down on the bed. If I don't print on the bed, then you will just have a big glob on the end of the 3D printer when you're done. So we're going to move here, and I'm going to rotate this around. And if this is blue, that means it's contacting on my piece. So then I would hit slice, start slicing, because I'm ready to 3D print this. And you tell it which extruder. I have a 2 extruder unit, so you can pick the left one or the right one. In my case, I always pick the left one. And you tell it what type of material and your infill, etc. And then you'd say slice. So I'm just leaving it whatever the standard is. So now it's going through a slicing program. And what it's doing is it's calculating where the actual nozzle needs to print everything out. So now it tells me that it's done, so I can preview. So I preview this guy here, and then go full screen, and then here I can check out each layer. So I'm going to come around, have it here. Now take a look at the top. This thing's going to slowly erase down. So I go like this, and it slowly erases down. Now the cool part is you can zoom in and see and say, oh, I want more fill, or I want less fill. I want more walls. You can do that, go back and change it before you actually print it. And that is how I get the file. So I would turn around here and I have the file. I can load the file onto a USB stick or to a flash drive or send it through Bluetooth. Okay, so what we're seeing is a good example of a 3D printer in action. The pattern that the machine travels dictates how you lay the part out and also how the part is designed. You can't have any overhangs or free hanging space because you can't 3D print into outer space. Imagine this is like a tube of toothpaste. It has to sit on something. This is a good example of a honeycomb fill at 65%. The two most difficult parts about 3D printing is getting the part to actually stick to the table and then removing it without damaging the table or the part. This is a good example of multiple part setup. It dramatically reduces the amount of print time. The more area that's attached to the table, the harder it is to remove the part. For the columns, I went with a 1 thou over reamer, so 0.501. When you're reaming PLA plastic, you need to go at a slower speed and a constant feed to make sure that you're actually cutting on the workpiece. If not, it'll just rub and bend out of the way because it is a thin wall. I also went 1 thou over for the 1/4 inch dowel pins as well, so I used 0.251 of a reamer. Again, constant speed, constant feed, and no coolant. So what I'm going to do is I'm going to tap all of the holes that are in these two pieces. I'm going to tap them by hand. I'm going to use a spiral flute tap. This is a Blue Wizard. It's a 1/4 20, and I'm going to make it as straight as I possibly can. 3D printed PLA material taps beautifully, and because of the thin wall, it makes the tap follow the hole perfectly. So it's very easy to tap by hand if you concentrate on what you're doing. Now I'm going to cut this short and not show you me tapping all of the holes, but you get the general idea. We're going to assemble our base. So what we need is 2 1/2-inch screws, or bolts. In this case I'm using hex head, and I recommend hex head instead of Allen key or socketed cap screw. And I'm using stainless steel because it's soft. You want to use a soft bolt, not a hardened bolt, not a class 5, not even a class 8, none of that. You can use a standard 1/4 20 nut. I'm using stainless steel, or you can also use a nylock. So whatever you prefer. You also need 1 3/4 inch 1/4 20 bolt as well. These guys can be substituted. This cannot be substituted. This is the washer that fits in here that creates your spacing or your ring. I made this so it fits in perfectly with the radius. You can turn or machine one of these, not a problem, but the outside radius needs to be 1 1/4 inches, I believe. Okay. You can also turn around and make them thicker or longer so that your touch-off height is different if you want. That's fine. This is just the standard model that works really well with a lot of different things. So let's assemble. So we put our cap piece in here. We put our nut. Oh. Okay. Okay, into there. Put your finger there. Put the 3/4 one into here. I'm not using Loctite. I'm not even using the NAR lock. And yes, I'm using a cheap Allen key or cheap adjustable wrench because I didn't feel like bringing everything into the office. And we just tighten that down a bit. All good. And we put these two into here. Now when we tighten these down, we just want them tight enough to hold place. We don't want to strip the threads out of these guys. Make sure they're tight. You're not taking these out once they're in. So once this is assembled, it's done. Okay? So that's the base here. Now, what we have is 3 legs, and if you take a look, I don't know if you'll be able to see that or not. You see the lettering on there? It's standing above. So what I'm going to do is I'm going to actually sand this down, and because it's 3 points, it'll level out. This is a step you don't have to do, but if somebody sees you putting something that has divots on a surface plate, they might be a little upset with you, so let's not do that. Now, some guys like to give me grief saying that I'm putting stuff on top of my surface plate. My surface plate's actually underneath, where it's safe and clean. This surface plate has been retired, so even if I do injure it a little bit, it's not the end of the world. So what I'm going to do is I'm going to put 2 different pieces of sandpaper down, I believe this is a 150 and this guy here is a 400. So all I want to do is sand the bumps off of here. So almost done. Nice and smooth. There you go. That's our feet assembled. Okay, we're almost ready to fit our nuts into our handles. Now, one thing I want to talk about beforehand are these two bolts. I could not get an 1 3/4 bolt, so I'm going to use a 2-inch bolt, and the 1.5 inch was just a little too short, okay? Because this bolt goes into here, which in turn goes into here, which I'll show you in a moment. So I also needed to add more thread to here. So all I did was take a die, a 1/4 die, and then run the die down. Not that big of a deal. I wouldn't really call that machining because it's done by hand. So now what I'm going to do is I'm going to glue this guy into here along with the rest of these guys and glue caps on, okay? So basically what I'm doing is gluing the bolts and the knobs together and then using a bolt to hold it in place while it cures. I'm using 3M Scotch Weld Instant Adhesive CH40H clear. It's basically like contact cement. So basically I have the handle or knob 3D printed. The bolt goes in, some glue goes in the bottom. The knob casing, which your finger grips onto, goes on the outside of the bolt. And on the top I seal it with another piece of plastic so that the bolt is completely encased inside of plastic. Okay, let's carry on with our assembly. So what we have is we have 2 screws to install into here. These particular ones are 1/4 and they're 1/2 inch. And we have 2 screws, watch out, they're rolly, to install into here. They are 1/4 as well, and I believe they're 1/4 inch. These 2 screws will never come out. These 2 screws will require to be loosened and tightened every time you take your indicator in and out. So let's start by putting these guys in first. Just get them started. Ooh. Allen key tricks here. Okay. These 2 guys here. I guess we really didn't need the Allen key. Well. So now this is my 1, 2, 3 block. It's not quite 1, 2, 3, but it's close enough. So I'm going to insert this block into here. That weight allows this to sit down. If not, I don't want to have a $300 or $400 indicator tipping over, okay? So this is relatively light still, but with this, it's very heavy. So to insert this, we take our 3/4 screw, that guy into there, just like that. It's up against the 1, 2, 3 block. Now the 1, 2, 3 block will not come out. It's held in place. So now I'm going to take my pin, put it in, lift it up a bit from the edge, put this guy in here as well. Lift it up from the edge a bit. Now I can tighten these set screws down here. They don't have to be super tight, just nip them a little bit to hold things in place. And that's what this guy looks like so far with this part of the assembly. We're going to let this guy dry a little bit longer, the nut inside there, and then we're going to assemble this. Let's do our assembly here. So now what we want to do is we want to put our spring in first. So we put our spring into here, and we also need our spring to go into this area here. So let's hold off on that for a second. Let's take a look at the washers. These have to be stainless steel washers this exact size. I believe this is 5/8 by 45 thou. Okay? Because these washers are a certain thickness, they sit in between here and stops any of the side play when you're moving your indicator around. Your washer has a rounded edge and a sharp edge. The rounded edge goes towards the plastic piece here and towards the plastic piece here. So you have the square edges or the sharp edges on the outside. Now you want to put this circle piece onto the spring. So this assembly can be a little bit tricky to do. So we'll put this inside, compress our spring. It is difficult to see and difficult to do. At the same time, we're going to push down. Once the washers are past this first piece here, you got nothing to worry about. This won't come apart on you. Then line up this hole here so that we can put our dowel pin in. This is a quarter inch dowel pin by 2 inches, which will fit into here. Move this around. Don't let the spring get it out. Move it around until you find the hole. Oops, got to go forward. There we go. And then push this guy in. Should be a nice snug fit now. It's assembled. That unit won't pop apart on you by accident. It's pretty good so far. Now with that piece of metal in there, here, this is smooth action. Press this guy all the way down. Make sure that our spring fits. That clicking is our spring. I'm not using any force when I heard that click, so it goes all the way down with the spring that I have. Keep in mind your spring might be a little bit thicker and there might not be enough room inside the undercuts. So I got full range of motion here, which is nice. You want to actuate this a couple of times. So that's our maximum movement. Now normally I would assemble this straight up and down, but it's not good for camera angle. So let's start with these guys here. Just put them in a couple of threads. This guy here and a couple of threads here. Tilt this guy down here. This guy here, I'll slide in there. Oh. And go up and down relatively easy. And then when you have your indicator set, you lock it. That'll lock that from going up and down. And then you have your indicator adjustment here. So you can raise and lower your indicator while you're going up against your workpiece. So basically this is almost fully assembled because it doesn't have the indicator in there yet. Version 1 to 3, from prototype to finished concept. Here is version number 1. This is a proof of concept. It worked great, and it still works good, but it needs some improvements. So let's take a look at what we have. So we have 2 pillars for stability. Loosen these guys off. Moves up and down for different height, which is awesome. That feature stays on all of the versions that I've created. It has an adjustable indicator here by a screw. Let's take a look at some of the positives and some of the negatives. Some of the negatives in this case is there's a front load screw or spring. There's a spring right there. And one of the problems is the spring has a tendency to pop out, which is bad. Another problem is if we take a look, we have a teardropped tool insert for our indicator. I didn't think that was a problem when I designed it. I thought, wow, I could put multiple different styles in. Absolutely the wrong way to go. Make this one and done for your standard indicator, not multiples. In the back here, we have an adjusting screw that's only threaded into plastic. Plastic's great for threading into, but not for a translation, a moving of a part. So to upgrade this, you need to put a nut inside of here. The base is great. So let's take a look at our base. So our base is made up of these 3 buttons and then a 4th button turned with a relief on it. And that will work great. The only problem that we run into is this plastic is so light that it makes it tippy. It's very tippy. It's easily tipped. And when you have a $300 to $500 indicator on here, you really don't want your indicator falling off and hitting anything. So that's some of the improvements some of the things that need to be improved. So let's take a look at version number 2. This here's version number 2. So first of all, it looks a little beefier. Second, the base is a fully machined base. So I CNC'd this out and then ground the ends. Way more stable. There's no tippiness here anymore. And it has a good hand feel. I like that. Our concept here, we have a lock, still goes up and down nicely. We've changed from a front load spring to a rear load spring. That makes the fine adjustment easier. And we've changed from the teardrop to a single indicator. Works great. Now here's time for some of the drawbacks. The concept that I want to make is, I'm doing this for apprentices and people that are new to machining. Everybody should be able to check squareness. So they shouldn't have to machine everything. If we could turn around and come up with a design where there's no machining involved, that would be awesome, because then you could just turn around, buy the parts, put it together, and you're done with it. So CNCing the base is out of question for most apprentices, at least within their first year or two. So this is out of the question. We just can't use this. We got to come up with something simpler and something that has the weight to it, because when we start making the base lighter, it has a tendency to want to tip, and we don't want that. So that's a thing that we need to improve. Now, another thing that we need to improve, or we improved on this model, is we have an arch here, and inside of here, I'll pull this up, there's a bolt in here. So that bolt is metal on metal, which gives your fine adjustment a really nice mechanical movement. And there's a spring on the inside. And we have our bolt lock here, dual locks on both sides. The only problem with this here is the spring holder is only on the bottom and not in the arm. So that's an issue. Also, an issue with this is this guy moves back and forth a small amount. There's some play in here. It's not a big issue, but on some of the 3D printed models, that play it's a noticeable amount of play, which you don't want. And all of these bolts, or it's okay, because I said we're in prototype mode. They're just bolts. They don't look nice. So let's take a look at our third concept. Remember, my goal is to remove all of the machining and just 3D print and do assembly. So on this here, a little bit of machining. I'm going to say if you have 3 months in the trade, you should be able to machine those buttons down, not a problem. This one here, you probably need to be able to program this. You probably need a good 2 years in the trade to be able to machine this one. Now, if you take a look at this one, size comparison, this guy's much bigger. But before we get to that, I want to talk about this piece here. This is hollow, and you can see how hollow it really is. Okay, that's very, very hollow. So to make the weight concept, to get this down, I inserted a 1, 2, 3 block. So you can insert the 1, 2, 3 block. All of a sudden now that's really heavy. So we don't need to worry about weight anymore. And it doesn't have to be a 1, 2, 3 block. It can be any size block, even rough cut on the saw. So what I did is I turned around and I'm using a washer, a stainless steel washer here. I'm also using standard stainless steel bolts. They don't have to be, they just need to be soft. They can't be hardened. And I'm also using a drill rod, standard 1/2-inch drill rod. Nothing special about that. Cut it off with the saw, hit it with the, do this way. Just saw cut and then hit with the grinder to make it look a little bit nicer. Now this guy here, we improved our holding tool here, our indicator holder by quite a bit. So this is the old concept, this is the new concept, where this is a 2-piece and this guy here is a 1-piece. Keep in mind, this is designed to be 3D printed, so it's not quite necessarily what you'd want to do if you were machining this raw. You have your standard indicator holder here, and our indicator holder. Okay, so I wanted to explain why these holes here are offset. So this one's on center, this one's offset. So this one here would hold a high-end indicator where your indicator mount and your indicator tip are in line with each other. So that's why this guy's here. Now if you take a look at this one, the indicator is offset. It's not on center. And it's not on center by about that amount. So I've offset this so that the indicator tip will be on center. If we take a look here, there's a space here for a bushing, which is really a 1/4-inch stainless steel washer on either side. And there's 2 screws here and here. There isn't one on the front anymore. And those 2 screws hold the indicator, and it adjusts the tip if it needs to be adjusted one way or the other. So those are the major improvements on the indicator holding arm. Also, if you take a look, there's a spring holder here, and on the new one, I should be able to see it on the back here. There's a indent here for the spring to go inside. One of the problems is when you get it down low, the spring will pop out. So now it's held in the top and it's held in the bottom, and that spring's not going anywhere. I also put a standard bolt inside of here, or nut inside of here, and I also put a metal plate here. So that metal plate is metal on metal, so the action of adjusting this in and out, up and down, is very, very smooth. Okay, so what we have here for this base is we have a piece on the top that just fits in here on top of a washer, and then we just have a bolt and a nut. You can use a NAR lock here, but you don't need to. These here pieces, when you see the assembly part of the video, they're just sanded down so that they're flat. Now the concept with this one is the triangular concept to make it a wider base so it won't be tippy. And I replaced all of the just screws with knobs. I like them, they look a little bit nicer, and then I did a fancier knob up top here. And that's the evolution of over about 5 years. So this here is my proof of concept. This is my working model, and then this is the newest one that you guys are just seeing it now. It's first out. No machining, except for reaming and tapping of the plastic, and it holds a 1, 2, 3 block for weight.
Let's set up and use the Squareness Comparator.
Okay, so now I want to load my indicator in here. So just load it in. Now there's 2 screws here. By adjusting one screw more than the other, I can actually change the angle that this sits on. You want it to line up perfectly with this nut in the center here to be in the center of this arc. A little there, and a little there, and that looks pretty good. This is also, because these are 1/4-20s, this is a 1/8 Allen key. You cannot check squareness unless you can check parallelism. So when it's this way, this is kind of in the way here. So if we take a look here, do we see how the line comes in? We can only check a small amount here. The nice thing about this concept is I can take this off, flip it over 180 degrees, and then I have a much more area here to check over. So this is a squareness checker or squareness comparator, and it also acts as a surface gauge as well. Okay, I want to check this block for squareness. So when I'm setting this up, I want to be able to come in and not have too much pressure on my indicator tip. So I need to lift this up a small amount because you want to be at the maximum amount of height when we do our indicating. So I can lock this in and I can adjust this here until I touch. So I'm going to turn this around so we can see this. Zoom in. So I'm going to be adjusting with my top dial here, or top knob there, to bring my dial into place. So let's see here. And we can set it to 0. We'll rotate this around a small amount so it's a little easier. We'll rotate that guy into 0 position. Now I need to double check to make sure that I have repeatability. So I'm going to move away and I'm going to arc in and get my highest spot. Okay, that looks reasonably good. Now I'm going to rotate my block 180 degrees. Come around and check this side. That looks pretty good. So I know this block is square, but I knew that before I started. Okay, so let's say this block isn't square. So what I'm going to do is I'm going to put a little bit of tape here. Just a little bit on the bottom. So now we know that this block is not square anymore. So how do we measure and calculate how much it's out? So what we'll do, okay, now that we have our tape on the bottom, we're going to bring our indicator in. We'll go to the front here. Okay, not quite there. Let's adjust to get to 0. We'll say right there, 0. Okay, that's side 1. Let's go over to the second side here. And that's, we'll call that 12. So it's 15 plus 12 is 27. 27 divided by 2 is going to be 13.5. So therefore, with the tape on the bottom of here, that makes this block out 13.5 thou out of square. Let's recap this again. So let's say this is my block. Let's pretend it's square. So this side and this side are the same length. So I put my indicator up against here, and my indicator reading says minus 15. I put my indicator read here, and let's say the indicator reads plus 3. So 15 plus 3 equals 18 divided by 2 equals 9. Therefore, this block is out of square by 9 thou.
Okay, let's take a moment and talk about 3D printing. Okay, let's say you don't have a 3D printer. You can get them printed in multiple different places. If you go on to Facebook Marketplace or Kijiji or any of the other social media sites, there's someone that will print this for you for a very small fee because these parts don't take a long time to print. Here is a link where you can download the STL files. When you click on the link, it'll bring you here and you'll have the opportunity to download them. This was an extremely long video, but the best is always at the end of the videos. If you're a training institution or you're printing these off for someone else, if you send me an email, I will change the name on the top of the base from Shop and Math to whatever your institution's name is. Something else worth mentioning, on a couple of the camera shots, there is some parallax error because where my eyes were meeting the indicator compared to the level of the camera, so some of the numbers may have looked a little bit off, but that's the reason why you might not have gotten the exact same view that I got. Also, if you enjoyed the video and you got some value out of it, please like and subscribe. It's free and it'll help me out. If you have any ideas on how to make this better or a different concept, please leave them in the comment section below. Thank you for watching the video and have a great night.